Hello, welcome to another community stand-up. I'm here with Shay and Bryce this week. We don't have any Jeremy this week. I believe it's his birthday. So if you're watching, which I really hope you're not, then happy birthday. But we have Bryce, who we talk about a lot on the show. He's on the EF team, does a lot of work on migrations and tooling and all that stuff. Migration bundles for EF Core 6.0, so that's going to be cool. And Shay, also on the EF team, but before he was even on the EF team, the author of NPG-SQL, maintainer of NPG-SQL, the AD provider for Postgres, and the EF provider for the EF Core provider for the same thing. So he's going to talk to us all about EF Core and Postgres. So we'll get into that in a minute. Before that, let's just check on the state of the unicorn. It's all about one thing at the moment, and that is that RC1 is on NuGet now. I'll prove it to you, and maybe that will encourage you to go download it. See, there it is. RC1, 7,000 downloads since last week. Download it, try it. So basically, it's feature complete. So if you want to see what's in EF Core 6.0, then look on NuGet now. There's one feature coming into RC2, which is a column order attribute. But other than that, everything is in there. Let's quickly go over some of the things, the highlights. We've talked about a lot of this already on previous episodes. Temporal tables, we're going to do a blog post on that. Migration bundles, Bryce's big feature here. Better Cosmos support, we've talked about that as well, and there's a blog post on it. You can now scaffold from an existing database directly to many tables. We have better support for group by, translating more patterns. You can set default value conversions. So for any property of a given type, you can say, I want it to convert to a string or whatever else. We have compiled models. We talked about that on the show before. So better startup time if you've got big models. We have generally better support for nullable reference types. The whole code base now uses nullable reference types, so when you're referencing EF from your own code, you get all of the correct annotations and everything there. Plus, we do scaffolding now of code which uses nullable reference types. So better support there. There's better support for split queries, especially collections that are not navigation. So when you're projecting a collection, you can use those better with split queries now. And perf, we've talked about this before, but big improvements in tech empower fortunes from the work Shay's done primarily. We're now pretty close, like within 4% of dapper perf on that. So awesome stuff there. There's a doc that's still a work in progress. I'm working on it this week to finish it off, but this is in our documentation. If you go under releases and planning and go under EF Core 6, there's a what's new section. And here we have lots of examples, it's pretty detailed. So that's temporal tables there, then migration bundles showing you how to use all of that stuff. The pre-convention model configuration for setting value converters, for example, compiled models, how you do that. This benchmarks, so improvements that we've done in perf for tech empower and compiled models. Cosmos provider enhancements. This is written but not published yet. And then there's a bunch of stuff like there, new translations. So this is a pretty big document with a lot of stuff in it. And as always with our documents, we have samples for them on GitHub. So if you look on GitHub in the Entity Framework Docs repo and download this, we have in miscellaneous, new in EF Core 6, and then there are all of these samples. And all the code in that document comes from these samples that you can run and try and debug and all that kind of stuff. Since we're here, like we also have all of samples for all the other old stuff as well. This is a great place to go and try stuff out and figure out how to use stuff. So that's EF Core 6.0. The important thing is we need your feedback. So the reason we do these RC releases and we feature complete now is so that you have a chance to try it before we go RTM. After we go RTM, it's hard to change things. It's harder to fix bugs. We have to go through a patch process. You have to wait. So try it now. File your feedback now, and we've still got time to get stuff into the RTM release for any bugs that you find, or if something doesn't work right, or something's a really bad usability issue, then let us know, and we've still got time to fix it. So if you're one of those people that's listening to this, then you're one of those people we want to go and get it off NuGet and give it a try. It's got Go Live license, so as does .NET Core 6, so you can even put it into production. First-party teams in Microsoft, I don't know if I'm supposed to say which ones, but they're already using .NET 6 in production, so give it a try. So yeah, try it. Okay. Yeah. So let me now pass it over to Shay, who's going to talk about Postgres.
Cool. So hi, everybody. This is actually a talk I've wanted to do for a very long time. It is a Postgres talk, but it's also, so it's about Postgres and EF Core, but it's really also geared towards generally, database people. So if you're using SQL Server people, which is what most EF people are doing, this talk is definitely meant to be relevant to you, and I'll call out certain things. So the idea is also to use Postgres to, dig under the hood a little bit and show you how things work and how things can work a bit differently. This is not just for people using Postgres at all. Having said that, I personally believe Postgres is the best database in the world. So I'm going to show you stuff I'm enthusiastic about. So what is Postgres? Just like in 2 seconds, Postgres is a relational database, exactly like SQL Server or like Oracle or like MySQL, a little bit like SQLite. SQLite is a little bit of a different beast there. It originated, it comes from that, it's an old school Unix kind of project. This is something that originated mostly in the Unix world originally. It looks like that. It's very, very, so it's written in C, by the way. It's extremely lightweight. I remember I actually had to work with Oracle about 20 years ago. a bit more now. I'm really old actually, and I remember the footprint and the management, like installing Oracle and getting to a state where you can actually connect to a database with something extremely heavy. SQL Server vastly improved on this, but sometimes when I install Postgres next to SQL Server, I feel a little bit like this. So a Postgres like instance running on my laptop takes like tens of megabytes in principle. It's very lightweight. You can start and stop it like extremely extremely quickly, and that doesn't mean that it's less serious database. So it has this Postgres is with MySQL. These are the two major open source databases used in production systems around the world. It's considered, both of them are considered very good. Obviously Postgres is better, but anyway, doesn't matter. We won't go into that. Every major cloud provider nowadays basically sells you a managed version of Postgres. So Microsoft has it on Azure. You can go and get like a managed Postgres. You also have hyperscale versions of Postgres. So similar to various other hyperscale things, you can go. Microsoft bought a company called Citus Data. Yeah, I'm not going to spend too much time on this. I want to get to the code as quickly as possible. But the idea here is that this is a very lightweight kind of open source and free, by the way, database as well. So there's no licensing and so on. But on the other hand, there's the whole enterprise part of it and officially recognized part of it, where it is in use in major enterprises. You can buy support contracts. You can buy them from instances from cloud providers. It's a real thing. This is not like a small thing that is only used in whatever small shops or something like this. In general, since it's a relational database, it looks a little bit like SQL Server. At the superficial level, it's going to look and feel exactly like any other SQL database. You use SQL to interact with it. So at that, it's standardized. It's actually one of the more standards conforming supposed to be kind of database. So there's something called the SQL standard. Unfortunately, databases don't necessarily follow it that to the letter. That's like a big problem. There's a fragmentation there. Postgres is supposed to be a bit more standards conforming. I guess it doesn't really matter to end consumers whether it's that standards conforming or not, since other databases are not necessarily standards conforming. So
as an ORM author, I absolutely love how compliant it is.
Yeah, definitely.
That's cool to hear. Yeah, absolutely. And then, in EF Core, it's going to feel, you're going to see this in 2 seconds. It's going to feel pretty much like a SQL, like SQL Server, or if you're using SQLite or MySQL. One important point, which we never get tired of repeating, is that EF Core doesn't attempt to be like an abstraction that hides away your database. That's always an important point. So certain details are going to leak through. Postgres is not, you can't just swap a database provider and everything works. That doesn't work because it cannot work this way. Databases really are different. Some notable examples is that Postgres is case sensitive when you do string comparisons by default, predominantly, whereas SQL Server is not. So if you're just taking your code across like that, that's not going to work. The list of types that you have in Postgres and in SQL Server, there's a subset that's very standard. Like you have strings, you have ints, you have timestamps. Although that's complicated. That's pretty much going to function the same way. But the moment you step out of that, things are going to be very different. So I remember coming from Postgres, you come to SQL Server, and there's this whole mess around. You have varchar, but you also have nvarchar if you want Unicode. So that's already two types. That's a bit weird. And you have, varchar with, 50 in parentheses, or you have max if you don't want to specify the size. And that's very important. You can't define like an index or primary key on the varchar max. It's all kind of complicated. In Postgres, you just have something called text, and everything is managed behind the scenes. And basically, there's no perf. There's not supposed to be any sort of perf impact. There's no advantage in saying, oh, I'm going to do a varchar 50. You can, but it's a validation thing. It's not like a perf thing, or there's no limitation of indexes, anything like this. So types work differently. They're not meant to be. They will never be completely, abstract across databases. When you make a when you attempt to do a database agnostic, application, you have to keep all that in mind. Do I have anything else I want to say? One last thing, I guess, which is important, is the perf aspect of it. Two more small things. So the perf aspect of it is quite important. So Postgres, Postgres is fast, but even more than that, a lot of effort has gone into the npg-SQL driver and EF Core provider, mainly the driver. It's just a personal passion of mine. I've always been interested in perf, and I happen to be the Postgres guy. So it so happens that npg-SQL is the more performant database driver in general, coupled with the database at least. I'm not gonna. I think the MySQL, by the way, provider is also very fast, but then the database itself also has perf difference. Basically, what I'm trying to say is, if you look at the Tech Empower benchmarks and you see ASP.NET up there in the top 10, which is where we are, .NET is in a very, very good place. That's running with Postgres. That's not running with any other database. It's important to mention it. That doesn't mean, by the way, EF Core, that's, by the way, running bare ADO.NET. There's no EF Core there. EF Core is also quite good in its category of full-fledged ORMs and so on. And as Arthur mentioned, we've done some major improvements to non-tracked query performance. So that's going to probably shoot us up a lot in the EF Core side of things. But once again, the perf aspect of Postgres support in .NET is very important to me, and it functions quite well. And the last thing, and that's related to my last point, there's a distinct advantage in maintaining both the ADO.NET driver, the low-level database driver, as well as the EF layer that is kind of layered on top of it. When you control like the full stack, you can do all kinds of things which are more difficult. So when I get excited about a feature, I can implement it all the way down, EF Core, ADO.NET, whatever. Whereas when we want something in SQL Server, then we work on top of SQL Client, which is a different team, which has different priorities. That's understandable. That's just how the world works, of course. Things work a little bit differently, and they may be a little bit slower in terms of introducing the newest kind of features. I think any comment on that?
No,
Arthur?
I was just gonna go back to the perf thing and just say that we're looking at .NET 7 and EF Core 7 planning, and we have even more ideas for perf there. Some of the other Tech in Power benchmarks, we're gonna look at those data updates, for example. So yeah, more perf stuff's coming. There's always more perf to do, and we're always going to get faster. So
I was
we're looking
working
forward
on
to that.
I was working on the SQLite perf, and I was chasing Postgres. I thought for sure, like, oh, I'm just a tiny in-process database. I can catch it, right?
Yes.
No, I couldn't. Like, it turns out, like, offloading all the CPU to another computer and going over the network. I've always been told networks are slow.
Yeah.
No, apparently, like I couldn't even catch it with SQLite, which is crazy to me.
But on that point, another thing that I didn't mention, because it's not really an EF Core 6, but Microsoft Data SQLite, which is one of Bryce's projects that he pretty much does everything on, that has connection pooling in 6.0. So especially if you use an encrypted database, but I have to say, I thought it would only really be useful in encrypted database. No. Even when you're just using a normal database connection, which is literally opening a file handle, right? I mean, it's nothing, but it's still faster with connection pooling. So that's an awesome thing on SQLite.
Yeah, Sebastian from the Orchard team had some tests, and he saw amazing throughput increase. I don't know why you'd be running Orchard on SQLite, but apparently he likes it.
Very cool. Yeah, ADO.NET has this thing where in general in .NET, you tend to open and close connections a whole lot, like a huge amount. So you really lean on, open and close being very fast via pooling in general. And I guess even, opening a file, that's a system call, and you're doing it a lot. So anyway.
So before we go into it, let's just there's one question here that comes up quite a lot. Is it possible to write database agnostic migrations in EF? For example, one that works on PostgreSQL and on SQL Server. Bryce, do you want to answer this?
Sure. I'll start by saying, like, the up and down methods within a migration, they're kind of like a DSL. If you want to hand author some, it's just like writing SQL that would work on both. You get a little bit through our DSL of like migrator.create table and stuff. But it's going to be really hard. It's going to be very manual. Our recommendation is just to keep two different sets of migrations, one for SQL Server, one for Postgres. It's just a lot easier that way. I'll just say that. But in theory, it is possible. It's going to be a lot of work, and you're going to have to test it a lot.
So this identity seeds that Anton pointed out here is different, and that's one of the things that tends to be different across all the providers, and so that's one of the things that is often set up differently in migrations. So to Bryce's point, yeah, having two separate sets of migrations is generally the best practice. You can write conditional code. You can generate two migrations and merge them together, and then have, if it's running on Postgres, do this. If it's running on SQL Server, do this, or MySQL, do that. It's probably not worth it most of the time, but it is possible to do that.
Yeah. Cross databases is a particularly, it's hard. It's basically hard to keep the same application working on multiple databases. It's not a trivial thing. It's like another layer of work that you have to do in general. But that's unfortunately the reality of things. Okay, so I guess I'll start diving in. Can we bring up my screen now? That this would be
yes,
the right moment for this. Awesome. So this is going to be a full-on coding thing. I don't have any presentation or anything. Everything is just I'm actually going to switch and just look at code now. I have no idea what anybody else is now doing with their faces or anything. You'll have to flag me with audio if you want my attention in some way.
Sounds good.
Yeah, so I have a very basic kind of template, which I'm going to use to develop stuff on. So what you see here is we have like, super basic blog entity type class. It has an ID, it has a name, which is required to simplify some things. We've got our run-of-the-mill context. We've got, our DB set of blogs. And here we've got on configuring, which is where we configure our, the provider and so on. And we've got our two database providers here. So by what I have uncommented here is SQL Server, which is running on my laptop. And we also have a commented outline for use PostgreSQL, and we're going to switch back and forth a little bit to show the differences between them. I've got simple logging enabled so we can inspect the SQL, and the thing basically just blows out the database every single time and creates it again, so we don't have any sort of state leakage. So the first thing I want to show, so I mentioned this thing with types, right? Databases have different types. So one funny thing with Postgres, they like types a lot. They like extensibility a lot. So there's a lot of support for very weird things that people are not used to seeing in the database. So what I'm going to do is, now mind you, I'm on SQL Server at the moment, right? So I'm going to just go and add an IP address field here. If I'm slow, you're going to have to be a bit patient with me. And I will just run this and see what happens. So this, once again, is SQL Server. If we look at our create table, then what we see is that IP address is a field of nvarchar 45, right? So this is what you're seeing here is obviously not any sort of IP address field or data type in SQL Server, right? What's happening here, people might know about this, is value converters. So SQL Server, or in general EF Core, comes with a built-in value converter, which if your database doesn't support IP addresses natively, what it's going to do is it's going to say, okay, I know how to convert an IP address into a string, so I'm just going to set that up for you. We can even, just for fun, we'll even seed like a small, let's add like a blog here. So a new blogs, add new, I'm going to use the target type, the new fancy stuff here. I'll put a save changes here.
You're using a top-level application there as well, which is
cool. Yeah.
That's no program main or
very
anything.
True.
It's writing at the top level. So
very true. The perfect thing for demos, exactly. Yep. So I'm going to parse. I'm going to do like a thing like this. Just parse some IP address.
So that IP address class, that's something that ships with .NET in the BCL, right?
Right. Yeah, that's a good point. So this is something that comes with .NET. It's there's another one for physical addresses, for example, which we also support. This has nothing to do with EF Core. It's just some class that comes, for networking. And once again, if I run this thing and we look at what it does, yep, then
it throws.
It throws. Why does it throw? Already, my demo has failed. I've reached my first thing. Have I? Oh, yeah. OK, so we need, because the name is not nullable, we have to, of course, add a name. So that's my fault. Let's add a name.
You put required on it to make it easier, but it actually
exactly. As always, that's actually going to help me out later. So that's kind of cool. But of course, no matter how many times you practice, you still get it. So if you look at what we're inserting here, this is important. I want to drive this point home. When you have this simple logging kind of thing, you see our parameters. We have the parameter P0, and here we have our IP address. This, once again, is a string. What you see here is that this is actually a string, okay, because value converters have made it so. So what I'm going to do now is I'm going to basically comment out SQL Server, and I'm just going to do PostgreSQL, and we'll see the exact same thing running on a different database. So this is going to look a little bit different, but not that different. So we have a lot of double quotes where before we had these square brackets to which SQL Server likes so much. So things look a little bit different, but you guys shouldn't get panicked. It's all SQL. It's all like a database. However,
it's SQL standard SQL, double quotes.
In fact, it is SQL standard. That's actually true. But yes, I didn't want to be the one to go. Thank you, Bryce. So what you see here is something very different. So name is something called a text. Once again, no nvarchar, no 45, no nothing. It's just a text field. It's just a string. But here we don't have a text. This is because PostgreSQL and Postgres natively supports an IP address type. So you can actually write that in. Why is that interesting? Why would somebody want something like this? So it turns out, first of all, this is basically validation. So in a string with the value converter approach with SQL Server, you can put anything you want, right? Nobody is actually enforcing that the string is an IP address. Here, if you try to put something that's not an IP address, you're going to get a validation error. So it's better like data constraint, consistency validation, and so on. But Postgres also comes with quite a bit of functions. So if you want to ask if a certain IP is in a range, like in a subclass, in a class C subnet or whatever, you can actually do this in the database, and that's going to be efficient, which is kind of far out when you think about it. So if you're using Postgres to manage like a fleet of machines with IP addresses, that's actually going to be maybe a bit useful for you. The main point I wanted to show with the insert here is this looks like it's the same, but the DB type here is an object, so this is not a string. This is actual native support for IP addresses in the provider. I'm going to step back for 2 seconds. This is not that impressive because how many people actually need IP addresses in their databases? Not that much, I know. The point here, first of all, is that I tried to do this like back in the day, maybe 4 years ago, I think, with EF6, with the classic, not the new EF Core 6, but the old EF6. And this was not possible. The old type system was closed. It basically had like, we support these types, string int and so on. We don't know about IP addresses, presumably because at the time, Microsoft was a bit more SQL Server centric, and the list of supported types tended to correspond to what SQL Server had. So if you're a Postgres guy or a MySQL and you have another type you want to support, you could not do this. Whereas EF Core is designed from the ground up with this concept of we're open to other databases and to extensibility. And I was very pleasantly surprised with EF Core that I could just, write a bit of code, do a little bit of glue, and this actually works. As is. The other cool
to just go into the internals for those interested. So what happens in the type mapper is so the type mapper is used when we're building the model. So when we see a type of IP address in the model, it gets passed through the type mapper. And the first thing the type mapper does is say to the provider, hey, do you handle this type? And if the provider says, yeah, I handle that type, which NPG-SQL or Postgres does, then we're done, right? We use the whatever mapping the provider gives us because it's done. If the provider just says like SQL Server or SQLite, it says, nope, don't know what that is, we then go look for a built-in value converter. And so if we find a built-in value converter, we say, oh, okay, we'll use that instead. So it's kind of like transparent. You just, if the provider supports your type, you get it natively. And if it doesn't, you get the value converter. And you really don't usually need to even know which one of those is happening.
True. And this is the same thing. I mean, some people know about value converters because they've used them explicitly. When you can, we're actually going to do that in a few seconds. It's the same idea. So there's a set of built-in value converters, which Arthur wrote all of them. And then if you don't have one that fits, if you want to do something special, I'll give you just a second. If you want something special, then you can set one up yourself, right? In addition to the built-in ones. Now, Arthur.
I didn't write all of them. In particular, the IP address one
That's
and
true.
the physical address ones were submitted by a community member. There was a community contribution to do those. So that was
That's
pretty
very
cool.
true.
And we also, by the way, the default is to strings, but you can also convert them to just like a byte array as well if you want to do that. And they support IP6 as well as IP4. Does anybody use IP6? I guess they do. I don't know. But anyway, they're there.
Cool. So yeah, so let's move on. So the other cool thing about Postgres is that Postgres, unlike any other database I know, but I might not know all databases, is very extensibility oriented. There's a first-class concept of an extension in Postgres, which you can install into your database. These can provide new types. So there's an extension that gives you something called L-tree, which is a little bit similar to what people in SQL Server know as hierarchy ID. So it's a hierarchical kind of thing which you can create. In fact, all of the spatial support in Postgres is delivered in a very well-known extension called Postgres, which is like a huge, very important kind of extension. It's supposed to be extremely good compared to other in general in terms of spatial support. So Postgres is very, very extensibility oriented, and it's important that EF Core allows us also to take advantage of it. But I want to go ahead and get to the more interesting stuff. So again, IP addresses, nobody really cares that much about. So I'm just gonna blow this one away right here. What people do want to do sometimes, however, if we're on a blog, is to have, let's say, a set of tags that we tag our blog with, right? So somebody coming into this world with, not from a SQL kind of, background or whatever, would expect to be able to do something like this. Just define an array, right? Just like I have a name on my blog, I want to have like an array of tags on my blog, right? Why not? I'm going to switch back to SQL Server and I'm going to run this thing. And obviously this is not going to work, right? Because
Well,
SQL Server.
We should make this work in the same way that we did the IP address, and there's an issue on the backlog to do that, where we can just take and do some mapping to SQL Server that works. But you're right. Right now, it doesn't, because SQL
So
Server
the question is if there's a value. So okay, let's that's actually a very important point, which what Arthur just said. So I'll get to that in a second. So what EF Core here is telling us is exactly what Arthur just described. So EF Core interrogated the provider, which is SQL Server in this case, and asked, do you support an array of string? And of course, no, it does not support an array of string. In this instance, there's no built-in value converter. So what we get is an exception, and this cannot be mapped. Okay. So now what are our options here? So first of all, I'm going to comment this for a bit. If you come from a relational background and you want to do things in the theoretical relational kind of way, you don't put an array property. We're actually going to do this the right way. Let's do this the heavy way, right? We create another thing called a tag. We give it an ID right here. Let's give it a property called the actual tag name, just so we don't confuse things, right? And now we set up, so EF Core 5 introduced an amazing many-to-many kind of implicit, like a very nice many-to-many support. All we have to do is say that a blog has a list of tags. We'll call it tags, quite naturally, and we'll do the same thing here. I'm going through this because we're going to see the other patterns that we can do. And here we have a bunch of blocks. So what we've done now is basically a many-to-many setup, right? There's a blog with many tags, a tag with many blocks. And since EF Core 5, when EF sees this kind of thing, it says, okay, there's a many-to-many. We're in a relational database. So I'm going to set up a join entity, which is the third table in the middle, blogs tags, which creates, the many-to-many relationship. Let's take a look at this. Let's actually run this for a second. So if you look at the actual SQL happening here, we have just created 3 tables. There's a table of blogs, there's a table of tags, and there's the join entity, which is implicit in our model. It's not there, but EF Core created it by convention. So we've got our 3 tables. Even more importantly, I'm going to do a query here. We don't really care about this seeding right now. What I'm going to do is, let's just do, let's get out all the blogs. And what I want is also to have for each blog include the tags, right? We want to like suck it all out of the database like this with async. The query that we get out of this is a classical many-to-many query, okay, which is this thing which you have right here. The crucial point here is that we've got 2 joins here. One left join from blogs to the join entity, and another inner join from the join entity to the tags. 3 tables, 2 joins. Now, this is the way that you're supposed to do it if you're reading a SQL textbook, right? This is like the way to model a many-to-many relationship rather than having some sort of array. The problem with this is very typically perf and general heaviness of your model. It's a complex model. It's also very heavy. One of the major sources of perf issues is joins. This everybody should be aware of this. So in general, when you're doing, you're optimizing or modeling for perf, you have to think about reducing your joins in general. That's done many times through what's called denormalization. You want to basically cut down on your joins in various ways, because finding that those entries which correlate across different tables is a heavy task. You're asking the database to do a lot of heavy lifting. Okay, so we don't want to do this kind of heavy thing, but we're still on SQL Server for now, right? We haven't yet made the switch. So what's the alternative, lighter kind of way to do this thing? I'm going to kill this, many-to-many model which we have here. I'm going to bring back, our array. And what we're going to do here is we're going to set up a value converter to save on some typing speed. I'm going to just drop this in from the outside. This is what it looks like more or less. So what you have, we're configuring the property tags on blog. Okay, so this is the array property, and we're configuring an explicit value converter. So this is exactly what happened before with the implicit one, with what we saw with the IP address. What we're saying here now is when we're converting to the database, when we're sending something to the database, we take that array and we join it. This is just a method in .NET, join it with a comma. So we stick a comma in between every one of those entries in the array, and we send that as a string. When the values come back, we do the opposite thing. We basically split it by a comma, and we build an array out of that. So I hope that's pretty much clear. This is actually going to work if we look at it. It's supposed to work. It's once again not actually going to work. No. Yes, we, of course, left the include, which doesn't make any more sense because there's no more entity with that kind of thing. So what you see here now is something that is extremely light. So if our goal was basically to store a bunch of tags on our blog, on each blog row, then we've done this in a very, very light way. Yes, we are now parsing and joining. We're doing a lot of string kind of stuff when we're reading and writing, but this is in a way much lighter and a much better solution depending on what we want to do. The problem here is what happens when we want to start asking questions like, give me all the blogs that have a certain tag, right? Like we want to start querying and selecting blogs that, according to a certain criterion. At that point, we're kind of stuck. We could use some, some very ugly, hacky kind of string things. So we can ask, give me back all the blog rows where the tags string contains this thing, but we have to be careful of the commas, right? This is exactly not the way that you're supposed to kind of program things in general. You want to do things in a nice way. So we're finally going to do the switch to Postgres. And Postgres, this exact scenario is handled in a much better way. It turns out, so I'm going to just comment this thing out, and I'm going to switch databases, and I'm not going to change anything else. So once again, we just have a property with an array type on it. If I look at this now, we've created a database, and what we have here is a first-class array type in Postgres. So in Postgres, every type that you have, text, int, whatever, timestamp or whatever, has its corresponding array type. It's a natively supported thing, so it really is it by definition is available for every single type, and you can simply map an array directly to this. So this is supported at the ADO.NET level, so you can basically just take a C#, a .NET array and send it to a Postgres array. And in EF Core, this is also mapped, so that the mapping goes all the way up. That's kind of like this stack thing that I was talking about before. This is as simple as you could think. We don't have to do any sort of joins, but on the other side, we don't have to do any sort of string operations, joins, or splitting, or anything of that sort. What's even better about this is because this is a first-class Postgres type, you can actually do operations on it. So let's do, what should I do now? We can also see this, by the way, as a sample, because I want to keep showing what this looks like. If I do this kind of thing here, like foo and bar are two label names, you're going to once again see that we're sending, that's in the insert, yeah. We're basically sending a single parameter here. No, sorry, that's the name. This is the one. With the type array of string, and the DB type is object. So we're inserting directly, we're sending directly like a .NET array into Postgres, which is a pretty cool thing.
We're supposed to have support for printing that better in EF Core 6. Are you using 6 here? I assume you are.
We are on 5 here. I didn't.
We're on 5 here. So
we are on 6. Should I switch?
Small well, but one of the small improvements is that
it's supposed to have a Go Live license.
If your parameter is an array, we give you like a little at least the first few elements of it. We don't fill your whole screen up with the entire array if it's huge. But
yeah, that's true. That's actually true. We got a request for better support of this kind of thing.
Yeah.
Yeah, I'm just here. I'm using 5 for safety, like for ultimate safety kind of. Not that I don't trust EF6. Anyway, now let's go and do some more interesting things with this. Let's say we want to do some sort of query on this. So what we want to do now is get out, basically the thing I wanted to say before. We want to get out all the blogs where, there's the foo tag, basically, okay? This is already something that breaks down when you're using the value converter thing. So the limitation of value converters, at least right now, we have some ideas on this, but right now, when you use something with a value converter, you can't call any methods on it in a query, right? We don't know how to translate this. All value converters give you at present is the ability to serialize something back and forth into the database, but in the query pipeline and the query expression, you cannot invoke any methods and expect them to get translated. However, since here we're not using value conversions, we're using native support, and the provider has written with this, we can actually try this. So let's see what happens now. Okay, what we see here is some weird thing. Okay, this is already out of the domain of what most people know, right? What we see here, this is the B tag, so this is our array. Here, there's this weird operator squiggly thing, which is the Postgres array containment operator. Postgres loves, by the way, operators. There's an explosion of weird operators. There's operators with 3 and even 4 characters, I think. It's really very, very, very advanced. And here, what you're seeing, this is a little bit weird. Foo is what I actually wanted to ask. This is the containment, right? But what we're doing is constructing an array around a foo. So it turns out, for some bizarre reason I couldn't find out, the containment operator is basically a set operation. So what you put an array to the left and array to the right, and it's going to tell you if this array is contained in this array. But it doesn't have an overload that allows me to just put a scalar here. So what the provider does when translating this is it builds an array around it, which is fine. I mean, there's no problem with doing this. And then we ask whether this array, the tags on every row, contains this array, which is the literal thing. Okay. Of course, since I'm me and what I care about is perf, then what we're going to do now is we're going to switch into a perf thing, and we're going to look into how this thing fares. Okay. Nope, I copy pasted it incorrectly. 1 second.
That's interesting, because we had a question here about some complicated thing about the end text heap and all of that stuff if you have ints and everything. So yeah, that's related to your perf thing, maybe?
Maybe. I need to understand the question a little bit better, I guess.
Okay. I thought you might understand. It's all Postgres to me.
Postgres stuff. Okay. So first of all, I'm just going to execute this query, right? Just so that people see. When I have the response here, we have just one row, right, that we seeded in our application. You can see this column, and here you have this, what looks to be like this composite thing. It's a string, but in fact, it's actually an array. So the string is just a representation. I hope everybody understands that this is properly like an array on disk, in Postgres. It's just being represented here as something like this. Now, when you want to know how something fares, you want to look at a query plan. Every time I talk about this whenever I have an opportunity, you have to always take a look at the query plan, basically to know if your query is going to run fast and if it's going to use indexes and whatnot, right? So in Postgres, the way to do this is different from database to database, is you basically prepend explain like this, okay? So I'm going to run this thing, and instead of getting a response, what I get is a query plan. What we see here is that Postgres is now doing a sequential scan. A sequential scan, for people who are not aware, means that we're going over the entire table. In this case, the table is pretty small, right? It doesn't have a lot of rows, and it's applying our filter. So this is how it's kind of planned to do this. Now, if we want to start looking at perf, the first thing we want to do is probably to add an index to this thing, right? That's like the first thing you do when you want perf. So I'm going to add an index now on my thing. Arthur, feel free to stop me at any point.
Yeah, I will. After you get through this, maybe we can talk about JSON columns a little bit.
Absolutely, I have that on my plan as well.
Okay.
I just hope I'll have enough time to get
around on that. So yeah.
Okay, I mean, I have a section meant for this. I just hope we'll have enough time, but I'll try to not. Yeah, I'll try to get ahead. So I'm going to recreate my database now, so we can see my index actually getting created here. Right. So my index is here. And now I'm going to switch over to my, let's get this down here. And we're going to run this. I'm going to see this running much faster, right? We're not going to see a sequential scan anymore. So we are seeing a sequential scan, in fact. Can anybody here tell me why we are seeing a sequential scan? Can anybody help?
I can't. This is database stuff. I don't do database stuff.
So what's the first rule of checking performance in databases is you have to have proper data in your databases. If you have a table with one row, that's just not going to fly always. Why? Even if we have an index with one row, that Postgres makes a very, very easy decision. Postgres basically knows I have an index, but what do I care? I have a table with one row. I'm just going to check it, basically. And there's a threshold there. Even if you put 100 rows, it's still going to be more efficient to actually go and do a sequential scan over these rows. There's some sort of cutoff, very mysterious. Nobody knows. Nobody should actually know this. There's some sort of cutoff at some point. There's enough rows, and Postgres, the planner, the query planner, decides, okay, now I'm going to start actually using this this thing. So the main lesson here for everybody, whether you're using SQL Server, Postgres, SQLite, or whatever, if you want to get actual query plans, if you're doing perf work on your queries, please seed your database with actual real-world data. If your table has a lot of rows, you need to seed a lot of rows. So what I'm going to do here,
I should have known that, because we did a show on this, right, on query plans, and you said that in that show, so I should have remembered.
In fact, every time I do a show here, I basically repeat this thing. Like the next time I'm going to do a show, we're going to have this moment again.
And I also remember, I don't know who brought it up, maybe it was you or somebody else on that show, but make sure you've got a similar kind of variety of values. Don't put null in all of them. Don't put the same string in all of them, because sometimes databases are very smart about that kind of thing and will still do different things if the data doesn't look right.
True.
Yeah.
So the best way is to have an actual copy of your production database,
Yes.
but be careful of GDPR and privacy stuff. But basically, you want something resembling your production data set as much as possible. That's the ideal world. So I have a fragment here which I copy pasted, which is going to insert 500,000 rows, which is well enough to satisfy Postgres instead of in terms of using the index. That took 6 seconds before. Yep, about 6 seconds. Okay. So now we have so many rows that obviously this is going to now work, right? So I'm going to run this, and obviously it is still not going to work. So what you see here is something a little bit different. This is how presentations work. There is something a little bit different. Postgres now uses something called two planners. So it's actually doing something called a parallel SQL scan. It has enough data that it's decided to spawn out to run the query in parallel. This is like some improvement that they did in some recent version of Postgres, I think in 13, which is what I'm running on. We don't really care because the hated words, sequential scan, are still there. This is what I want to, eject from this thing. I don't want to see sequential scan over 500,000 rows, right? So what gives? What's the problem here? Obviously, I've done my homework and I've run this before, and I'm not getting caught here with my pants down and so on. The thing is that what we're looking here at here is a much more complex thing. Okay, we're not asking. So a normal index, what does a normal index kind of do? If we do an index on a string, we're basically gonna reply to all queries that check for rows where that column has that value. But what we're asking here is get me back all rows where that column contains a certain value. So what you're seeing here, if our query checked if the array equals to some array, then a normal index would work, because just like similarly, a string column equals a string. But what we're asking for is a containment operation here. And a containment operation requires a different kind of index. So Postgres has this idea of index methods, or we can call them index types here to not use weird terminology. You have various different types of indexes which you can define. I'm not going to go too much into this, but generally when you have a complex thing like an array and you want to search for something inside that array, then you use what's called a gin index. You do it like this. So this is, now we're in Postgres specific land. We're telling Postgres to create that index with the gin method. Gin is an acronym for generalized inverted index, which basically means that the data is pointing from, so we're inside the array, right? We're in elements inside the array, and the index maps it back to the array. Anyway, I'm not going to go into the theory too much because it's not that interesting. I'm going to run this again. So now we're doing really Postgres specific things. The index that gets created now has this weird bit here at the end called using gin. Okay, this is the weird stuff, let's say. Now, this thing blew away my database, so I'm going to seed it once again, which is what I'm supposed to do. So I'm building a different kind of index now, which hopefully is going to be able to support this query that we're running here. And now we finally have a very different query. Okay. Now we have an index scan as opposed to a sequential scan.
Yay.
Yay, right? Exactly. To summarize, just to make sure people understand, we've stored an array into a column now, which is a very, very weird thing. And we've also created an index which supports containment queries into that thing. Now, I think that's pretty cool. I'm not sure if people actually appreciate this. This gives us a lot of, what you can do with many-to-many, but without all the, the heavy normalization and joins. So it can be seen as a perf feature. If what you're looking for is perf, it can be looking as a simplification thing. If what you're looking for is simplifying your models. There's various aspects around this. Anyway, I find this like an extremely cool kind of feature. Can I show just one more thing around this cool array thing? Yeah, cool. How am I for time anyway? I need to.
Well, we're 6:45. Oh, sorry, that's UK time. We're 45 minutes in.
That's okay. Yeah, that's not so good, but I'll run over by about 10 minutes, I'm guessing. So the one extra thing that I wanted people to see, this can go even further. This is like a very cool thing. Let's say we have multiple tags here that we want to filter on. So we have the tags foo and bar here, and we want to find, or foo and blah, doesn't really matter. And we want to find all blogs which have any of these tags. Okay, this is like a much more serious, much more complicated query. It's not just a simple contaminant thing. So the first question is how we can express something like this in LINQ. We want all blogs where their tags array contains something that is also in this array that we have here. Okay, so I was thinking about this at the time, and I came up with something like this. So we basically are going to ask if the tags has any tag, which the tags from the outside contains. So this is a kind of a complicated LINQ query now, right? It's I hope people kind of get the idea of what this is. This is basically, if you think in set theoretical terms, this is an intersection, right? We're basically asking if the intersection between the rows tags, which is b.tags, and the external parameterized tags, if the intersection contains something, if it's not empty, okay? If I run this thing, this will actually work. This is the amazing thing. What you see here is something that's actually far simpler than the LINQ query. This is not something that happens that often. It so happens there's an operator for an intersection, which returns a Boolean. So whether the intersection is actually empty or not, and that's perfect. So what the EF core Postgres provider does is it identifies, when it's translating LINQ to SQL, it identifies this pattern, which is already quite a complex thing. We call this pattern matching in the expression tree. And when everything aligns correctly, then it will emit what you want. And this query also uses the GIN index that we defined earlier. I'm not going to show this because I hope people trust me that I'm not lying, but this is actually a fast operation, and it's quite a complex one as well. So I personally think this is pretty cool. Are there any questions up to now?
There's been questions around, whether or not it's actually faster than using a normalized database schema and things like that. But I think you already covered a lot of that.
Yeah, do a benchmark. You will see every join. If you do like real world data, you're doing like if you're doing a many to many, so 2 joins, you're gonna feel it. Absolutely.
And then we had this question about shouldn't it be named for NPG SQL has method or something?
Awesome question.
Yeah, so I can answer that, I guess.
Yeah.
When we were first working on EF Core, we did have these long method names to avoid having clashes between different providers. It makes it nasty for 99% of people who are using one provider or when the methods don't clash anyway. So if you really have 2 methods named the same and you need to use them both in the same application, you can switch to, instead of using it as an extension method, just using it as a regular method call, which isn't quite as pretty in your code. You can add your own extension method somewhere that wraps it and does your own thing. But it's kind of one of these things where balancing it, we're like, do we really want to make everything you do on SQL Server be for SQL Server do this, and everything on Postgres for Postgres do this? And we decided no, that's just making it horrible for everybody. So yeah, we changed that. And then I guess going back to what was being asked before was around JSON columns, and like could this not be stored as a JSON column and then use the JSON query stuff to query into it?
Right.
Which, I'll let you.
So that's a good question. I'm not sure I'm going to have a lot of time to talk about JSON, unfortunately. You definitely can have a JSON document. JSON is something that came later. So arrays were here in Postgres like a long time ago, and at some point JSON appeared. There's still a lot of value specifically in arrays because they're more constrained and more restricted. A lot of things, many things are more already optimized and done for them. A lot of the things that you do here, I would say it like this. So NPG SQL does support JSON mapping. If what you want to do, if the intention is to map an array, use a Postgres array. There's many advantages in doing this. If you want a hierarchical data structure, that's going to also be like weakly typed. So, key values and things and whatever, sure, use JSON. But if it's really an array of ints or an array of strings, like in our example, like arrays are the better fit.
So we have a question there. When can we expect RC1, Shay, of NPG SQL?
I'm moved by how much, so it's been a week and I've received so many requests already. So I apologize to everybody that, RC1 isn't out yet. There's like one big change that everybody will see once it's out. That's been, been taking more time. Yeah. A few more days, like really a few more days, I promise. This is like my highest top priority thing on my plate right now.
So going back to the JSON thing, so there's been questions about, can we do this on SQL Server? And I think, Like, is there equivalent to this, the gin index on SQL Server? I'm not aware of anything, but if we think about the JSON thing, it may not be as specific and as optimized on as using the array type, but you could use JSON on SQL Server or Postgres or MySQL. Unfortunately, the Postgres provider and the MySQL provider have for EF Core have support for that JSON mapping JSON columns and querying them. We haven't done that on SQL Server. We hope to do it in 6.0, but it got bumped out. Resourcing. So once we get that support, then across the board, you should be able to do things like this with JSON columns, which will let you run queries into the JSON, and that will be a pretty good, more general solution for multiple providers.
Agreed. Okay. I'd like to show one more thing around arrays. I'll try to do this as quickly as possible so that we do get to talk about JSON just a little bit. I'm going to switch back to SQL Server, which means I need to have my my conversion and all that kind of stuff for a second. And what I'm going to do is I'm going to flip it around. So I've commented this out, and what I'm going to do is a different kind of query. I'm reminding you guys, we have a name field as well. That's, by the way, also required. So what I'm going to do now is I'm going to do the exact opposite. Instead of checking blogs which have a certain tag, what I'm going to do is we're going to query for all blogs where the name is one of a list. So I'm going to instantiate an array here, blog 1 and blog 2. And that array needs to contain the name in order for the row to match. So we're in SQL Server, back to SQL Server land again, because I have something very important I want to show people. Hopefully I've done everything right and I don't get an exception now. Wow, amazing.
Yeah.
Okay. Yay, exactly. So this is fine, right? Everybody's used to this. This is what we want. The contains thing, the contains construct in C# and .NET is translated to a construct called in. I hope everybody's familiar with this code. Nothing to see here. The interesting bit, the important bit, is what happens when we parameterize this array. So if we don't want to check for the same two blogs every single time, but we get them as a parameter, say from the user, blog names, let's call it, then we're going to have an external thing here. Blog names, not blogs names. Exactly. And we're going to run this again on SQL Server, and then we're going to see something very interesting. So what you see here is the same thing. The point here is that usually when you pass something in as a parameter like this from outside of the query, EF Core parameterizes it, okay? It sends it out of band. It's not in the SQL. It's going to be a parameter that's sent out of band, and the SQL is going to be the same regardless of which parameter you sent. This is important. Parameterization is important for in EF Core, at least for matters of perf, because the moment you have the same SQL all the time, then query plans are getting reused. EF Core internally caches various things. It's very important for perf not to switch your SQL all the time. However, in the world of SQL Server, since we don't have an array, we don't have an idea of an array, we can't send this blog names, which you have here. There's no way, it doesn't mean anything to do this. The only, what EF Core has to do, what EF Core is forced to do, is to do what we call internally constant expansion. So we take that array, and the moment we need to execute it, we're going to expand it into constants and inject it into the SQL. Now, once again, it makes the query work as expected. The results are correct, but there's various perf problems around this. And this is not a trivial thing. People using this kind of pattern with a huge amount of, say, this array could have like 1,000 things, right? If you're running this kind of query a lot, you're basically bypassing your SQL Server query cache. You're causing internal EF Core caching to not work as efficiently as it could. That's not a good thing. Now, once again, if we switch back now and go...
Just to interject there are also additional complications around parameterizing variable length parameters. So, for example, if you have a contains, and sometimes it's got 10 elements, sometimes it's got 15, sometimes it's got 27, and every time you run it, it has a different number. Then if you try and parameterize that on SQL Server, you end up with basically different query caches, different entries in the query cache for all the different numbers of parameters, and that can be a problem for your perf as well. So that whole area is pretty complicated. We do some stuff now. We have on the backlog to do some other stuff. It's something that Diego Vega, when he was on the EF team, used to think about and come up with ideas for a lot. But it's a pretty complex area. So anyway, back to the Postgres.
Yeah, unfortunately, it seems so simple, right? You're just doing it
Yeah.
contains like in your link query. It's a world of pain behind the scenes, really. It's really very complicated to do. However, when you have a first-class array concept in your database, which is what Postgres does, and we run the exact same thing, once again, I hope everything is correct. I've successfully transitioned back to Postgres. We're going to see something very, very different. So the construct that you see here, there's no longer an in word, there's an any word. And what you see here is a parameter. Since Postgres has a first-class idea of an array, you can use it not just as a column, you can also send an array parameter. Doesn't matter what length it is, exactly what Arthur was referring to before. You can send, one query execution is going to have a length of 2, another query execution is going to have a length of 4. Postgres doesn't care about this. This runs extremely efficiently compared to the SQL Server one because you have the same SQL every single time. And that's, once again, a pretty cool thing. I'll just say one thing. I'm going to jump ahead a little bit because I want to get to like at least a few words on JSON. This thing also runs efficiently if you put an index on name. Okay. In this instance, you're going to just use a normal index, just like any other index. If you look at this, if you think about it a little bit, this corresponds to asking whether bname is equal to the first element of blog names, or if it's equal to the second element of blog name. So you can expand this, logically speaking, in your mind to a bunch of ors. And a bunch of ors can be, of course, optimized by using an index. So this thing is also, again, very, very optimized. But notice that the translation here is very different from what we saw before. We don't use the array containment operator like before. We could have used it, that squiggly with the at greater than sign. It's an alternative translation, but each one is going to use indexes differently, depending on whether this is just the string or whether this is an actual column, which is an array we're looking into. So the provider is actually using a lot of smarts when it's doing its translation to choose which construct in SQL to use so that you can use your indexes. This is basically my point here. Translation here depends on whether your array is a parameter or a column. I think that's a pretty weird point. We don't have a lot of these cases in EVE Core. We do have some of them, but this kind of different expression based on parameter or constant or column, I find pretty cool, and it's nice that EVE Core can do this again.
One of the advantages of using an ORM, I mean, you often hear people talking in the disadvantages of using an ORM because you can write more efficient SQL, but at least I know that I don't know all these things. I don't know when I need to do this translation versus that translation versus the other, and so having a provider that's actually able to figure that out for you, you can end up getting more efficient SQL out of an ORM than you would write by hand, unless you know everything in the world about Postgres and SQL, and then fair enough. But I think for the average developer, it's one of those big advantages of using an ORM.
I agree. I tend to agree. So usually you should be looking at your SQL and you should be understanding what's going on as a developer if you care about perf. But it's true that in this sort of instance, this is pretty persuasive kind of demonstration why an ORM can actually sometimes be a little bit smarter than you in terms of crafting your SQL and avoid certain pitfalls and problems, even in a provider-specific way. So it's going to do this specific crafting for this specific provider, for this specific database, which is, I think, a pretty cool thing. Okay, I'm going to jump to the thing I've been promising. We do have, let's say, about 10 minutes. So at least I'm going to do like a demonstration, a minimal kind of demonstration. So Postgres also has JSON support. All databases nowadays have JSON support. It's part of this move to bring in this kind of NoSQL mentality or philosophy back into the relational databases. And it's a very cool idea. We no longer have to choose either, the traditional relational world or pure NoSQL document database like Mongo or Cosmos or whatever. We can mix and match a little bit, which is obviously the right way forward. So you can model certain things in a relational way where you have a very strict schema and benefit from that thing, and where you need a little bit of fuzziness and documents and contain things rather than normalize them out into a many-to-many relationship, then you can use a more NoSQL kind of thing. In fact, what we just saw was a NoSQL kind of thing, right? What we did with the arrays was a NoSQL thing. But nowadays, it's all about JSON, right? That's like the cool thing, like for a very long time. Postgres actually has two JSON types, not even just one. It has two types. SQL Server, by the way, doesn't have a JSON type. It has a set of functions and operators which can be used to manipulate JSON data in text columns, which is a different kind of approach. In Postgres, the primary kind of way to do JSON is called JSON-B or JSON binary. That's basically just a type that contains JSON in your database, but crucially, it doesn't contain it as a text. So you don't just dump a JSON text into your database. What it does is it parses it and has some sort of highly efficient binary representation for the hierarchy of the JSON document. And that allows us to do various things in a more efficient way. For example, if you want to project something out of a JSON document, okay, let's say I have a JSON document now and I want to project, some subtree of that thing. If you do this on SQL Server or on Postgres with the older kind of type, then your database basically has to parse your document each time in order to extract that thing that you want to project out. Whereas when you have something that's already parsed and in an efficient binary kind of structure, then you don't need to do that kind of thing. It's already parsed on disk in a way, right? But again, let's jump directly into the code as quickly as possible. Let's say that I want to, have a JSON document here. So the simplest way that I can do this in Postgres is I have a string property here. This is not the cool thing, what I'm showing you. I'm going to go to the cool thing very quickly. And all I have to do is say type name equals JSONB. Now, this is a completely generic EF core mechanism. It has nothing to do with EF core, with Postgres, sorry. What it does, it definitely has to do with EF core a little bit. What it says is this string property, by default, we would map to a text column in JSON, in Postgres, right? What I'm instructing EF core to do now is to map it to a JSONB column instead. So if I create this database now, tags, where did I leave some tags? Yeah, no more tags. We're in JSON now. So if I create this now, what you're seeing here is that instead of text, which is what name is, this is a JSONB document. At this point, this is not amazing. What it does do, once again, is it parses it so the value is stored in an efficient way. It also validates, so you can't insert invalid JSON into this, which is once again an improvement, right? If you're just shoving JSON documents into text columns, you have no guarantee that what you have in there is correct. But the more interesting thing that we usually want to do now is to actually map a POCO, so a plain old C# object, into this kind of thing. So what I'm going to do is, let's say I put some class and I put whatever, some int property, views on it. And now I'm going to just switch type to be details. So if I run this, we're going to see the exact same thing. This is a little bit weird because what we've done now is we've created a C# type, right, a .NET type, and we've created a property with that type, and we've mapped that to the database. And what we see here is this. Okay, let's seed that thing into the database now. So we're going to do details equals new. Once again, I'm a big fan of target typing. Views equals 8. So we're now saving this thing into the database. All right. So we have this insert thing right here. And if you look at what we're actually seeding inside into details, this is an object here, okay? This is not a string. This is, let's say, a JSON object at this point. If I switch to my, let's zero this thing out. If I look what I have in my blogs table here, and what you see is, once again, something that looks like a JSON document, but you'll have to believe me, behind the scenes is not a JSON document as is. It's a binary representation of a JSON document. And it's inside one single cell, so one column, one row. I hope that's kind of clear. The interesting thing, of course, is when we want to start querying into this kind of thing. So what I can do now is ctx blogs. Now, if I want to start drilling down into this thing, I can do this. So let me do this after I seed my data. That's going to be a much more intelligent approach. So what I'm doing here is I'm doing a query, and I'm asking EF core to get me back all the rows where the details column, which is a JSONB document once again, has a views key whose value is 8. This all looks like plain old .NET. We're still doing just link. It just looks like a normal kind of thing. But this, usually when you see this kind of thing in EF core, this means that we're traversing a relationship, right? There's a related entity, and we're going to do a join or maybe a split query, right? Whereas here, we're in NoSQL mode, okay? The document is inside that row, which is the blog. It's in there, just like in Cosmos or Mongo or whatever. And if I run this thing, this is actually going to work, and you're going to see some weird stuff, right? This thing, I promised you operators, right? Weird operators. Here's, I've delivered on my promise. This is a weird operator, which is a drill down into an element inside a JSON document, okay? This is obviously It's obviously recursive. I could drill down into a lot more. I'm going to do maybe a very quick, just to persuade you guys that this is extremely cool. Let's say that this thing has let's create a class of orders. And on this is going to be like a price. None of this makes any sense in terms of a model, but we don't care. So we have orders here. Okay. And now let's say we want to, I don't care about the seating. I'm going to break this down. And I'm going to say where, instead of use equals 8, orders dot length equals 8. Okay, where there's 8 orders on that details thing. So if you look at this, the provider knows how to translate this as well. Oh, or it doesn't. Cannot get the length, the array length of a scalar. What have I done wrong? Is orders... where's the scalar here? Interesting.
It worked before.
It did work before. You'll have to believe me on this. Okay, we're a bit out of time, so I'm not gonna. You'll have to take my word for it that I'm not lying. There's a variety of operators and functions which the provider knows how to translate. There's an indexing story here as well, so you can create indexes. Once again, they're going to be GIN indexes because they're from the components inside the JSON document outside. They're inverted indexes, as we call them in Postgres. There's a certain set of scenarios where you can actually make this thing very fast. So use an index, exactly like you saw before with the arrays. It's a pretty awesome thing. The thing where this becomes limited, this was done as part of the Postgres provider, as Arthur said, and also in the MySQL provider, you have very similar support. It's done in a way that, for example, doesn't support partial updates. For example, we can't update a JSON document and replace one part of it. For example, using EF Core, you can't do this efficiently. You can replace the entire document, but not a partial update. We plan to look into this kind of thing for EF Core 7. I really hope so. The aim is also to bring all this goodness to SQL Server, of course, with whatever support is there. We'd have to, of course, look at what kind of JSON support is compatible across all databases and provide some sort of lowest common denominator, which hopefully will be substantial enough so that it's interesting. But that is a very exciting thing. I personally believe this is one of the major things that EF Core can offer, which is to query on JSON documents inside the database, once again, using pure, plain link queries like you're used to using C# like in general.
Absolutely.
Is your value converter still on there from SQL Server? I bet that's what
You're probably right. Well done. No, it's not.
No, it's not. That's...
I deleted it, but this worked.
Oh, well.
I promise. All right. Well, okay. I didn't have two major catastrophes. I had just one major catastrophe. So
the demo failed, but enjoy the cat.
Yes. Alice says, I don't often use databases, but when I do, I use Postgres.
Postgres, the database Alice uses. That's
yes,
the new
exactly. So we're over time now. I think we've answered a few questions. There's been people in the chat answering each other as well, which is always great to see. Can't answer the question when you should use SQL Server and when you should use Postgres. That's always a very complicated answer. Use what works for you. What makes sense for you, basically. But if you do, EF Core is a good choice for both of them. So hopefully you'll use EF Core either way. With that, unless Shay or Bryce, you have anything else, I think we'll call this one. And thanks, Shay, very much for doing all this Postgres stuff. I'm sure there's a lot more that we could have shown there, but it was really good digging down into some of those detailed stuff. Yeah, maybe we'll have to do another show in a year or so. Yeah. Okay.
That's okay.
Thanks, everyone. And I have to find the right buttons to press to end the show. So let me see.
With Alice on it.
With Alice, yes. Here we go. Okay, thanks for watching, everyone, and we'll see you next time.